Hello everyone. In this video, I'm going to go over how to do two-stage least squares in Stata. First, I will go through the procedure manually by running the first stage regression, saving the predicted values, and then running the second stage regression. And then I will show you the easy way to do it using the ivregress command. I have an older video where I do two-stage least squares using the ivreg command. Ivregress is better and more versatile, and that's what we're going to be using. What we have here is the wage2 data set that we've done a little bit of work with in the past. And I'm going to use this data set to estimate a Mincer equation where I want to know the relationship between wage and the years of education. I'll start by running our regression using OLS to get the baseline model. I'm using experience here as a control variable. Now, if we think that there is some omitted variable out there, such as ability, that is correlated with both wage and education, then this estimate of $76 of monthly wage per year of education is biased. The way that we will deal with that bias is with two-stage least squares. Now, what would be a good instrument for education? Well, possibly siblings. We've made the argument that siblings is probably correlated with education in the sense that families who have more children are less likely to be able to provide a high level of education for all of them. And siblings shouldn't be correlated with ability. If we think that ability is something that is innate to each person, that shouldn't be related to the number of siblings that you have, at least for the most part. The first thing that we'll do here is run the first stage regression. In the first stage regression, we regress the potentially endogenous variable, education, on all of the instruments. Now, we are going to assume that experience, or exper, is exogenous. So it will be in the structural equation, but also will be technically an instrument for itself. Therefore, the first stage regression will be regress education on experience and SIBs. The first thing to look at in the first stage regression is the significance of the new instrument, which is SIBs. Remember that we need this variable to be relevant. So we need SIBs to be statistically significant in the first stage regression. And we can see that this has a very large t-stat, so we are good to go there. Remember as well that there is no way that we can actually run a test for exogeneity, and we just have to make the argument that we think that it's unlikely that siblings and ability are correlated. Now, the way that two-stage least squares works is that we go back to the structural equation, which is this one right here, and replace education with the predicted values from the first stage regression. So we're going to generate those right now using predict. And you can name these whatever you want, but I'm going to call them educat. And the option here we're going to need is XB. I'll go to the data browser to check this out. We can see that the education variable is the number of years of education. It runs from, we see some 10s all the way up to some 18s for some highly educated people. If we go over to educat, these are the predicted values based on the number of siblings and the years of experience. You can see that these are generally in that same kind of range. Now I'm going to run the second stage regression, which is regress wage on educat rather than educ, and exper. experience. We can now compare this with the original OLS regression that we ran. We can see that the coefficient on education has changed dramatically. We can see that it went up by quite a margin. This suggests that we actually underestimated the effect of education in the original regression. This is interesting because we would have expected to go the other way if the ability was the only omitted variable, but this suggests that there are many other omitted variables out there that we hadn't considered. It's important to recognize at this stage that these standard errors right here are not correct. And this is because Stata does not recognize, while I did it this way, that educat are predicted values rather than actual data. To get the correct standard errors, we're going to have to use ivregress rather than doing the manual procedure like I just did. How ivregress works is I first type in ivregress. Now, the next thing it needs to know is the estimation method. And there are actually a few different options, but the one that we are using is 2SLS for two-stage least squares. So whenever you're running two-stage least squares, up to this point, it's always going to look like this. Now, just like with the regular regress command, we need to put in the dependent variable. And in this case, we have wage. Next, we list any explanatory variables in the structural equation that we think are exogenous, that is, that they can instrument for themselves. For that, we have just one, which is expr. And finally, we need to tell Stata which variables we think are endogenous, and that goes inside parentheses. So we're going to put educ here, not educat, just the original education. And if we think that there are any other endogenous variables, we would also list those here as well. Now, in this case, there was only two variables in the structural equation to begin with, so that wouldn't be the case, but we could put an entire list of variables right here. Then we put an equal sign, and to the right of the equal sign, our new instruments for these endogenous variables. So this is where sibs will go. And if we have more than one instrument, that will go in there as well. Now we're ready to run the two-stage least squares regression. What you can see here is that we get the exact same coefficient estimates as in the manual procedure, but we get slightly different standard errors, and that's because the correction has been done in these standard errors, whereas it has not in the ones above. Now, in this case, this didn't make any difference. These are all significant in both regressions, but in some cases, that is going to make a difference. Now, to give you a sense of how ivregress works with a more complicated model, let's just throw some more variables into the regression. Let's say that we wanted to add IQ into the regression. We wanted to add married into the regression, and maybe we'll try using the parents' educations as additional instruments for education. So to do this, I'll type ivregress 2SLS. As I said before, this is always going to stay the same. Now our dependent variable wage, our exogenous variables. Now let's assume for right now that experience, IQ, married are all exogenous. That might not be the case, but let's just assume that for now. Now, education is our endogenous variable. If we had more, they would go here as well. Equals now all of our instruments, so sibs, m_educ, and f_educ for mother's education and father's education. So this regression ran just fine, and we can see that we got another change to the education coefficient. The last thing that I want to show you in this video is how we test for endogeneity. I'm going to go back to our original model, this one right here, where we have just experience in education with siblings instrumenting for education. The way that we test for endogeneity is by first running the first stage regression, which, as you recall, is regress education on experience and sibs. But now instead of predicting education hat, we're going to predict the residual. So I'm going to just call that E residual. Residual being our option that we use to predict that that's what we want as opposed to the predicted values, the Y hats. Now, all we do is run the original regression, regress wage on education and experience. This is the structural equation, but now we add the residuals from the first stage as an explanatory variable and run this regression. The way that we test for endogeneity is simply to do a t-test on the significance of E. What we get here is a t-stat of 2.46 with a p-value just over 1%. So this would be a 95% confident rejection of the effect of E being 0. Therefore, we can be at least 95% confident that there is endogeneity here. Another interesting feature of this test is that it estimates the coefficients the same as in two-stage least squares. The reason for this is that when we replace education with the predicted values, the education hats, we're essentially controlling for the part of education that is uncorrelated with siblings, that is to say, the residuals. And we're doing the exact same thing by putting that into the original regression. However, remember, of course, that these standard errors are not the ones we want. So for the correct estimation, we really need to be using the ivregress command right here. That's it for two-stage least squares. If you have any questions, be sure to let me know. Thanks for watching.